Hi, this is Tracy at OSU, and I just wanted to introduce our speaker today and the topic. This is what it takes to build, maintain, and integrate 27 million, which is actually now 29.5 million square feet of BIM. I'd like to introduce Dave Pifher to you. He is our Architectural Services Manager, and he'll be starting off the conversation.
Okay, thanks. And Tracy is our BIM coordinator, so she's responsible for most of these processes that we'll be talking about today. So we're here today to talk about talk about the processes, tools, and technology that we use for our BIM initiatives at Ohio State. So our BIM initiatives are comprised of three components. It's BIM for existing buildings, so this is how we take our transition from our AutoCAD to Revit, and also kind of how we maintain those as renovation and constructions occur. And there's BIM for design and construction. This is mostly about our project delivery standards and how we'll receive the Revit projects at the end of the projects. And then BIM for operations. So this is how do we get all of the models and data into our systems and into the hands of our operations teams. So we've been working on this initiative for quite some time. We started talking about the transition in 2008, 2009. We started getting serious about it in 2010, developing some framework on how we would make this transition. And we really started the transition in 2011 on the medical center side. That transition took about 1.5 years. And then we carried that process forward to the rest of the campus buildings. And that's really where we are today, still working through that chunk of buildings. Also, I'd mention in around 2011, we started talking about if BIM made sense to us from a design and construction standpoint. Turns out it did. So we spent almost 2 years working on what we needed in our BIM standards. And our first standard was released in 2015. And that's been an iterative process, and we just released version 3 earlier this year. So BIM for existing buildings, this will be much of our focus today, and we also cover a little bit about our BIM to BIM, what we call our BIM to BIM process. And that's what do we do with those buildings that come in from the larger projects, and how do we get them standardized and into our system. So a little background on the project. We started out like most people with maintaining our buildings in 2D AutoCAD. This was great for tracking space and our basic needs, but we really wanted to move towards a data-centric model, being able to understand the exteriors and adjacencies, and really having a database of information about our buildings. So we're currently about 83% complete with the project. We have over 251 buildings and about 29.5 million square foot. We suspect this will take about 2 to 3 more years to complete our existing building stock, and that'll ultimately put us about at 35.5 million square feet. So when we started down this path, we really had to ask ourselves, what do we need to model? What do we want in our models? And what's the stuff that we don't need? There's a lot of things that you can put in the models, but really what supports our planning and operations efforts. Our team has always been under the planning umbrella of the university, so we really focused on what helps our planners, and our general goal is how do we help people make decisions faster. But we also wanted to keep in mind what could easily be maintained. At the end of this project, we're going to have a lot of buildings, a lot of models. So we wanted to make sure that it was reasonable for our team to maintain those going forward. So we knew we didn't need everything that comes in a project model. So it's not this design intent, work intent, or as-built, but it's really what we term as our as-maintained model or owner's model. So these are the items that are, I'm not going to read these, but these are the items that are in all of our base models. A lot of these were in our AutoCAD drawings. Inherently, we gained some things by going to 3D. But we've also added things like casework, plumbing, furniture, which we didn't track, like the open office areas previously, and also some equipment that was helpful for users. So at the beginning, we spent a lot of time thinking about what we needed in our template and developing that template. Our group was the only team on campus that was using Revit or had experience with Revit. So we wanted to make sure that this was going to be a cultural shift, so we wanted to make sure that the models were easy to navigate as you moved from model to model, that they look similar to our users. So the project browser and all of our models look like this. They're all consistent. The structure's the same as you go from one building to the next. So it helps familiarize our users with how they're set up. We also have all of our models open to what we call the splash screen. It has a 3D image of the building and some basic information about that. All of our models also have these 3D cutaway views that are preset in the model. This was really to help our planning teams as they started to transition and use our models. This would allow them to pull some quick pre-made views to do some of their work. We have some basic schedules, some room schedules, some equipment schedules, and obviously the standard floor plan sheet sets that you would expect to see. We continued that standardization into all of our naming conventions too. So all of our floor plans, ceiling plans, elevations, all of those, as you transition from model to model, are all standard named. And part of the standardization is, as we knew we were going to have that large base of models at the end of this project, so we wanted to make sure there was consistency from model to model also, because we knew automation would play a role in our processes at some point. And we carried the standardization naming into our family library as well. We settled on the master format, so this helps us to manage and organize our library, but it also keeps things consistent versus naming them in a descriptive manner, which can get kind of messy over time. We also, in regards to our families, we thought a lot about what needed to be modeled. Did they need to be buildable versus representational? We settled on representational. We didn't need to know the exact make and model of the chair. Just a chair that looks similar to what you're going to find in the space is good enough for our planning needs. And also the same goes with our casework and sinks and things. They're just representative of the type of sink that you're going to find. It may not be that exact model. We also kept in mind tried to make as many of our families parametric as possible so they could be used in multiple ways. But we still ended up with the amount of buildings that we have. We still have over 1,000 families, and we'll probably add more as we continue down some buildings that we haven't yet, types of buildings that we haven't modeled yet. So this is our basic process that we put together. So at each May, we hire a new group of students, student interns that we train for 1 week. We provide that training is basically not only on the software, but also our processes of how we model and make our buildings standardized. We think of this in 3 parts: the gather phase, the build, and check. So that initial gather phase, they collect our existing drawings, as-built. They go out and field verify. They come back to the office. They start building the model. Once that's complete, it goes through a series of audits. The student starts to audit, and then it passes to Tracy for audit, and that kind of goes back and forth until Tracy says the quality of the model is good. And then it goes through the publishing process and shared out on our network and other systems that pull from there. So with that ever-changing group of students, we've been at this for over 8 years now, so we've had a lot of groups of students. So highly documenting our processes was critical to keeping these models consistent as we go from year to year. So we recently just moved to this web-based system, and that's also helped streamline the process. And with that, I'm going to turn over this to Tracy so she can talk in more in depth about our processes.
Thanks, Dave. Hi. After we train the students for a week in Revit, we go ahead and start with our setup process. So what I do there is I assign each student a building. I set up the folder structure. I set up the folder with the building name and number. I put the available AutoCAD drawings in there, and then I also arrange for the initial field verification. So the field verification is critical. It's one of the most important things that we do. If you don't do this right, it's going to take you longer to build your model. So I really stress that they need to pay attention and get the things they need to get. So preparation is the first thing. What I have them do is I have them go onto our GIS maps, or they go onto Google Earth and they look at the building. So I have them look at the exterior. Where is the building in relation to other buildings on campus? Are there any prominent features of the building that they would need to model so that they can make sure that they get pictures of it while they're out there? They also download files from our archive site, so they'll do project drawings, as-builts, elevations, sections, that kind of information. Next, they'll do the building walkthrough. So, before they do that, I'm sorry, during the preparation phase, they will take the AutoCAD drawing and they will dimension, they'll put several dimensions, usually 10 to 15 or so, within the model. They're dimensioning the length of hallways, the width of hallways, large rooms. What we do with that is when we get on site, we take those same measurements in the field, and then we come back, we have what we call the deviation worksheet, and we can plug those numbers in, the measurements from the AutoCAD and the measurements from the actual existing building, and see what the deviation is between the two of them. If the deviation is under 2%, then we will go ahead and use the AutoCAD drawings as an underlay to build the Revit model. If it's above 2%, then they're going to have to go and measure the whole building. Thankfully, we've not had too many of those, maybe one or two so far. So when they start the walkthrough, they'll take the AutoCAD drawings with them. They will walk every floor, they will look in every room. Some of the things that they're doing, they're looking at door swings. They're looking, have doors been added, taken out, moved, etc. They're checking room signage. Does the signage on the door or the wall actually match the AutoCAD drawing for the room number on the AutoCAD drawing? They're also looking to see if there's been any renovations that maybe haven't been captured previously, and if there are, they're going to sketch those out. A lot of times they'll come by cube farms or something, and they'll have to sketch out the cube farms, bring them back, and we'll number them for them. They're also adding components that weren't in the AutoCAD drawings, for instance, plumbing. So there wasn't plumbing in the university AutoCAD drawings, there was in the medical center, but not in the university. So they're adding plumbing, sinks and emergency showers if there's labs and that kind of information. They're also adding fume hoods and stuff like that, that are things that we want to track within our models. Also, while they're on field verification, they will take pictures. So I used to have, we started with a regular digital camera. I'd have them take a picture of the sign of the room, and then I'd have them go into the room and take pictures clockwise around the room. Because that way, when they come back and I know what room they're in, I can know always that every series of pictures is going to go in a clockwise direction, because I'm not going to the building. I'm not seeing it firsthand. I'm relying on their pictures in order to do my audit. Recently, we moved to 360 cameras, which are amazing. It's such a big difference. They're not missing stuff. If you take 2 pictures in a large room, 2 or 3 pictures in a large room, you're getting everything that you need. I'll have some examples later of how the pictures have really helped us. When they get back to the office, what they'll do is they'll take and they'll rename all of the pictures. So they'll rename it by room number. Say they took 3 pictures of room 100. It'd be 100-1-2-3. So I know which pictures go with which room. Because again, I said, I don't go to the building, so I have to rely on their pictures. If they don't take pictures, then if I'm asking them questions, they'll have to go back. So I stress they have to take pictures of everything. Once they get back, we can start the modeling process. So what they'll do is they'll open up a new model, and it'll bring in our template. So we have a template that's preloaded with our materials, basic walls, basic components, plumbing, casework, doors, windows, that kind of stuff. Because it's named according to our naming convention. I think David mentioned earlier that a lot of our naming conventions. A lot of our data information feeds into other systems. So everything has to be named correctly. And we also use a lot of automated tools, which Dave's going to touch on later. And everything relies on everything being named correctly and in the right format. So the first thing they're going to do is they're going to put in their levels. They'll get their as-built information. They'll find out, the distance between the levels. And then I have them pin everything. If you've ever worked on a large Revit model, you know that sometimes things kind of move around. So I tell them you need to always pin everything so it doesn't move. The next thing they're going to do is they're going to link in the AutoCAD. Now, there's a couple things that they need to make sure they do when they link them in. First, we want them to link and not import. Second is we want them to make sure that they check the box that says current view only. If they don't, then that AutoCAD drawing is going to be able to be seen in every view that's in the model. And we don't want that. We only want it shown on the floor that it corresponds with. So I'm going to go back to where the project browser is. And so here's the basement floor. When we go back in to link in the AutoCAD, here's the basement drawing right here, and that's what they want to do. They just want that drawing on that floor. After they do that and they have, some levels in there and some grids in there, they can go ahead and set the project base point. This is really important. When we first started the project, we were doing the medical center buildings, so we didn't have discipline drawings or any other things that needed to link into our model, so we didn't use the project base point for anything. But as we got into the project farther, this is like one of our lessons learned, is that the project base point is really important. And it's important for several reasons. First, they'll get the information that they need from our GIS system. So they'll get the north, south, east, west coordinates. They can get the elevation and also the angle to true north. And if you're not familiar with what the symbol is, it's right here for the project base point. But that information feeds into Revit. So if we have a Revit model that has discipline models that need to be linked into it, each model will have the same project base point. So when you go to link those in, they just stack perfectly. This also comes into play with Navisworks, BIM 360, and also GIS. Our models feed into our GIS. And so we need the coordinates to be correct so that the buildings are where they really are in real time in space. After they're done doing that, they can begin modeling. So what they'll do is they'll build the model just like you build a building. They're going to do the core, the shell, they're going to add the floors, then they're going to start on interior walls. When they're done with interior walls, and then move on to what the components are. So they'll be putting in casework and plumbing, workstations. If there's anything that's model in place, like a one-off thing, sometimes those happen, a specific registration area or nurse's station or something like that. When they're done with the modeling of the building, then they'll start putting in the room numbers. So this is where our space information comes from. This is how we track it. We have our room number. It's entered in here, and then Dave's going to talk about a tool that creates our space ID number, and that is where all our data is tied to, is this number here. So it's really critical that this is made correctly. So the other thing that we do is we always have our default at 8 foot. Our space is at an 8-foot height. When our information is exported out and brought into our SIMS, our Space Information Management System, if that space is going through the ceiling and into the next floor, it's going to show on both floors in our space management system. So it's going to show on the first floor, and if the space is going through to the second floor, it's going to look like we have two room numbers in the same space. So it's really important that they not change this information. So we've set it default at 8 is a good height, that it's not going to go through to the next floor. We also do our GSF at this time, so we will do GSF for every floor. We have schedules already pre-set up within the model in our template, And so the schedule will take whatever GSF is on that floor. So if you have more than one, it will take those, it will add them and give us a gross for the floor, and then it takes all the grosses and it adds those all together so we have a gross for the building. After they're done with that, they're going to set up views. So we have standard views that we require for every model. We have our our site views, Project North, True North. We have our space reporting views. We have our cutaway views, and that's the example that's up here. Like Dave said, this is really important. We use this a lot in planning. We have our standard elevations, our sectional views. So we'll do a north-south section, an east-west section, and those are standard. So if people want to see how the building flows on the interior. We also have them apply templates. So we have standard templates within our project template, and these are standard view templates. And so these correspond with the names of the views. So we have, if you notice, we have the site views. So we have a site Project North template, and we have a site True North template. We also have, our cutaway views. We have a 3D cutaway template and a 3D directional template. And what these do is they set up the views so that they're exactly the same in every model. There's certain things turned on in one view and certain things turned off in another view. So all the students have to do is just apply that information to the views that they've just created. So after this, they go through and they do an audit. So first they're going to look at the model, in 3D, rotate it around, make sure they haven't missed anything, there's no gaps and there's no holes, there's no shafts going through the roofs or anything like that. And we have several tools that we use to do an audit with. Now, when we first started this process, I would do the audits and it was all visual. Everything was visual. And sometimes it would take anywhere from several days to a week to audit one model, depending on how many floors there were, how many rooms per floor, that kind of information. But now that we have found some tools that we can use and automated some of that process, it now only takes several hours to audit a building. So the first tool I'm going to talk about is Celebri. This is a model checker software that checks basically geometry. We use this to check our spaces to make sure they're not going through to the next floor. We check to see if there's double spaces, if there's missing spaces. We check to make sure that, floors aren't running into walls and walls aren't, duplicated. There's a lot of geometry that this checks for us automatically. And then I just have to go through and verify the errors that Celebri puts out. So it'll put out the red triangle is critical errors, the orange triangle is not as critical, and then the yellow triangle is less critical. It also gives me a count of how many errors are in the model. It'll also tell me where in the model that error is. So if I select the error, it'll highlight in the model. So right here I'm showing two columns together. It'll highlight where it is in the model. Down below in this one information section, I can find out what it is, what type of column it is or what type of component it is. It'll give me the name. It'll give me the location. So it just gives me information about it. So then I can go into the model and make the correction. The next model checker we use is actually the Revit model checker. This is a free tool that you can download. And we have gone in and we have created a rule set that we use for this that is specific to the things that we want to check. And I didn't mention that about Celebri, but we also do that with Celebri. We have our own rule checker. We didn't use the out-of-the-box stuff because some of the stuff it checked for, we didn't need to have that checked. We wanted it to check for specific things, so we made a specific rule set to check the things that we care about, such as spaces and, clashes with walls and that kind of stuff. So in the model checker, the only thing the student has to do is put in the correct scale value. With our templates, we have all of the templates will have the same scale in every view. It doesn't matter what view you're in. It's like the project has one scale and you have to apply that to every view. So that's the only thing they have to change. They go ahead and they run this report. So this report is looking more like data information. So here's an example of an error report. And so it'll tell you, it's 50% of it passed. It'll give you a green if it's passed. It'll give you a red fail. You can open that up. It'll tell you what's going on. So with this one here, it's saying the third floor doesn't have the right view template set to it. And so there's a little show button. I can click that show button and it'll take me right to that view in the model where I can change it right then and there. You can't really see it here. Oh, no, this is the wrong side, sorry. So then after they're done with their audit, then they send it to me to audit. I do exactly the same thing they just did. I do a visual audit, I run Celebri, I run the model checker. I also have an audit process that I follow, which is also on the CAD to BIM website. And I will document things that they have missed. So if I'm going through and I see, you can't really see it on this slide here, but these closets here are not being shown as having a space in them. So on my screen, everything's light blue, except for these closets, they're white. So I go ahead and document, and I say on the 4th floor, there's closets missing. I do not put the room number in here because I want them to check the whole floor. A lot of times I will put the room number in if it's specific just to one room. So like the example down here below, it's the 1st floor, it's room 119, and I say, hey, it's missing the rolling window with the counter. This is something they miss, but was something that I was able to pick up because we had the 360 camera pictures. So those, I just can't tell you how helpful they are. They're like gold. They're just amazing. So after the model is done, the audit process usually goes back and forth between myself and the student, 2, 3 times, hopefully not 4, because if it's 4, we're going to have a conversation. But so hopefully it's just 2 or 3 times, and they'll fix the errors. I check it, make sure that they fix what they're supposed to, that they didn't break anything else while they were fixing it. So then we link in adjacent buildings. This is really good for planning because if someone's not familiar with the campus or it just gives them a visual of what is next to that model in real time, real space. We can also do combined building models. So this is where that project base point comes in. We can use this to have the buildings placed exactly where they are in the real world because we have those GIS coordinates in there. So this is our Ackerman complex that has 8 buildings, and we were able to make this so that they could have a view of the whole site. After the building also has been done, we ask the students to do renderings. We ask for one interior rendering. So this rendering here of the digital union is really what it looks like. It's amazing. This other interior rendering, we're inside the building looking outside into an interior courtyard. We also ask that they do exterior renderings so they can do day shots, they can do night shots, they could do a cutaway of the whole building. They could do, if there were adjacent buildings, they could turn those on and do a rendering with the main building and then the adjacent buildings on and just, parts of the adjacent building. They don't have to do the whole complex, but it just gives context. This is really good. This is kind of what Joe calls eye candy. It gives our leadership a chance to see what we're doing. It also gives other departments a chance to see what we're doing. If we're telling them about what we're doing and we give them the website for our gallery, then they can go ahead and go in and look, and then it spurs thoughts in them like, hey, how can we use this model? So we've had a couple departments that have come to us and asked us to help them to be able to start placing content that's important to them into a model that they make to link into the architectural model. We also have a BIM to BIM process, and so we call it BIM to BIM or B2B. It's when we get a Revit model in from an outside firm. What we need to do is we need to make sure that that model that's coming in looks the same way as all our models we've already made, our CAD to BIM models. So one of the things that I need to do is I'll need to go in and prepare the model. One of the tools I use for that is Ideate Explorer. I love this tool. It's amazing. As I mentioned before, we have standard levels that we use. Now, if you've worked with architects, you know that they'll have a million different levels, top of parapet, top of steel, lower first floor, upper first floor, and they have geometry tied to all of those. We only want the geometry tied to our standard levels. So with Ideate Explorer, I can go in and I can look at the level, I can sort by level, and I can then open these up and see what's on each level. So it really, really helps me in that way. This year they came out with something new. They have warnings, and so they have warnings that the program automatically looks for, like are there duplicate components? Do highlighted walls overlap? Is a tag outside of its room? So these are just basic things that you want to know that I don't have to go in and set it up. It's already in there by default. This is showing how Ideate Explorer has shown that there's 2 spaces on this floor that have the exact same number. So now I can go back to the room numbering prints and find out what is the correct number for this room. Then I also need to make the levels and the views the same. So if you see on this side of the screen, this is typical of what I might get in from an architect firm, and this is how we need to make it look so that it's set up for our environment. When that's all done, it's all cleaned up, we bring it into our OSU template, so that way it has all the views set up, it has all the view templates in there, it has all our families and things in there. And at this time, we also double check to make sure that the sea level is correct. It's very, very important that we have the sea level correct because these models are feeding into our GIS and we want the campus to be correct. We also have additional resources on the CAD to BIM website, and this shows our standard naming conventions, how we name each floor. If a student has a building with a mezzanine or with a tunnel, they're going to name it according to our standards so that every building looks the same. We have levels of model development. So we have everything for our base model in there, and these will be things that'll be in every model regardless of whose model it is. We have residence hall models. So Student Life has asked us, hey, we want to know how many beds are in a room. We want to know, is there a wardrobe? Is it built in? Are there dressers in there? Are there bunk beds or are they single beds? So we have that. That's additional information that's added basically to the base model is the things that they've asked for. Parking garage, so we identify the parking spaces. There's general spaces, your ADA, your leaf spaces, your valet spaces. At the hospital, they have valet spaces. They have your, ticket dispensers and all that kind of stuff also. Additionally, we are just beginning to do some of our athletic areas, so those will have other things that are added to them, like, hey, we're going to put the baseball field in, or the football field, or the basketball hoops. So I don't have that updated on this slide yet, but it's in process. And then just additional information. This is stuff usually found in our medical center buildings. There might be nurse stations. They want to know, dining areas. They want to know where labs are, lab benches are. Mailboxes, shelving, specialty plumbing, like emergency showers and eye washes and that kind of thing. With that, I'm going to hand it back to Dave to talk to you about our tools.
So in support of some of these processes over the years, we've developed a suite of tools that kind of help us with these processes and streamline some of the more tedious tasks that we do. These tools also help improve the accuracy of the data within our models because it removes some of the human error that can occur. So our first tool is what we call the subspace tool. As I mentioned, we weren't previously tracking the open office areas with that, so this space here would have just been room 125, not showing the individual workstations. So as we developed that, we come up with a subset of numbers. So in this case, this is cube 80, but it's still within 125, so it's 125-80. So our users will enter that into the room number field there. And then once they have all of those entered, they can run this subspace tool, and it will populate in our schedule the cube number. And it will also graphically take that tag that is shown within our drawings from the hyphenated number just down to the cube number, which cleans up the drawings once you have a lot of these. We also use this in lab benches as well. So it can get the drawing can start looking messy, so this helps tidy that up. But it also populates this field that is then pulled into our space information system. And previously they would have had to type this. And there just opens up to a lot of errors. You know, if you have a whole floor of cubes, by the time they're manually typing them, if they get out of order or whatever, it can cause data issues downstream. The next is our space ID. As Tracy mentioned, all of our spaces have a unique identifier across campus, so we call that our space ID. It's comprised of the building number, the floor, and then our room number. And previously, these would have to be all hand entered. So this tool basically still allows the user, just like before, to enter the room number. When all of the room numbers are entered, they run the Space ID tool, and within seconds it populates, it creates all of the space IDs by pulling different parameters that are already in our models and concatenating that number. So this drastically improved the time that it takes to do that. In a large building, this could take literally days for them to sit down and hand enter. You know, if we had a 23-floor building with a lot of rooms, that's a lot of work and very prone to human error. So this has really streamlined that process. The Closeout Automation tool, this is used in both as buildings are transitioned, and it's also used daily as we make renovation and construction changes in our models. So at the end of any change, we run this Closeout Automation tool. We always provide our users a PDF, the DWGs from the model, and an IFC. So this tool really allows us to do that all in one step. Previously, we would have had to go into the model and export one file type, then go back in and continue that till we got everything we needed. This allows it to be in one step. It also allows us to control the view templates that are applied to each of those different file types. And this also puts the files into the proper locations on our network, so we don't have to move them after the fact. And then the lower dialog there allows us to, this is more for our, you can see for SIMS there, so our space information and management system. We can select the floors that actually had physical change to them. So we don't have to export all of those. It allows us to pick and choose which floors we need to update in our space system. The view and sheet deleter, this is really a tool that was designed for our BIM to BIM process. As Tracy mentioned, a lot of things come in those models, so every view and sheet that was ever used throughout the course of that project come in those models. This tool allows us to, through the dialog, pick which items we want to keep and which ones we want to purge. So basically which ones have the geometry that we really want and which ones are extraneous. And it allows us to check those and literally delete those within seconds once we run this tool. So that's really helped the process in scrubbing our models and getting them more standardized as we get them from projects. The imported line and pattern deleter is a similar tool for the BIM to BIM process. This gets rid of purges any line and patterns that come in through those project models that we really don't need. And it also is used in the CAD to BIM transition as well, deleting those, the underlaid AutoCAD line work and stuff that we don't want to maintain in our model. The sheet creator tool allows our users, as we're creating these models, to basically set up one sheet, one floor the way that they want it. They can place one floor, and then from the dialog box, they're able to choose which other views in the model that they want to create sheets for, and then populate the revision date and their initials and things that we want populated in this title block. And once they run that, all of the sheets are created within, within seconds, literally, once they hit the run button, which saves a lot of time because they're not manually setting up all of the sheets. And then that also improved our accuracy of the building stacking. When they were doing this manually, the building wasn't necessarily, as you flip through the sheets, stacking exactly. This puts the building footprint exactly the same spot every time, so it's helped in that as well. The file archiver upgrader, this is really a valuable tool from my perspective if you're a building owner. Obviously, from year to year, we upgrade what version of Revit we're using. So this allows us to, versus opening and saving, upgrading and saving each model, this allows us to do a mass upgrade. It also suppresses a lot of the errors that occur during that upgrade, especially with our linked adjacent buildings. But basically, this tool allows us to point to our source files. So in our organization, we have a working network location and a public network location where the other systems pull. So we kind of have that behind the scenes, so we can point to that. It will create an archived copy of the current version in case something occurs during the upgrade. We have a backup file to go back to. And then it will upgrade the files in place. And also, you have the ability to populate that other directory in the public location through the same process. And in the dialog, as soon as you point to the source file, this dialog will also tell you if there's any corrupt files. So you're able to know that immediately and deal with those files before you trigger this upgrade process. So this has saved a ton of time. Likely, with the amount of models we have currently, it would have taken over a month for somebody to set their daily opening and closing, saving models. So with this tool, I'm able to trigger this before I leave for the day, let it run all night, and then come in and deal with any issues, address any issues the next day that we've had. So this last upgrade, we were probably at a total of 360 some models, and it took about 4 days for us to upgrade. So there's a huge time savings with this tool as well. So we're also working on trying to get our data directly out of BIM to our GIS. So basically our goal is to get both 2D and 3D GIS based on our models. Our current process for that, and Larissa Kruger is our GIS, she's manager. She's also within our department, so we work with her. If you have any detailed questions about the GIS portion of she's a really good resource for that. So currently they're exporting the RVZ file. They're running that through a specialized FME script and pulling the data that they need out of the models. This is really still a work in progress. Some of the challenges are that BIM is much richer in detail than GIS. GIS has only recently become fully 3D. And there's other issues that not all of the data is contained within the models. Revit inherently knows what spaces are, so coming directly from our models, there's not necessarily a polygon coming out. And there's also supplemental data as we get projects in. So things that are not necessarily contained in the model, but may come in like Kobe sheets. So next steps for us, we're in the beginning phase of implementing Revit Server and Clarity. We believe this will create additional efficiencies within our operations. We have departments throughout the university that are beginning to build on top of our models. So we have departments that are creating their own MEP models. We have departments that are tracking equipment. We have a group that is starting to look at tracking some interior things for, artwork and various things like that they want to keep track of. So we're sharing these models, but our organization is the way that we're set up. We have a lot of different IT networks, and this becomes a challenge as you're trying to manage getting all of their models back in one place to share with the rest of the organization and project teams. So Clarity will improve that process and allow us to share those models much easier. It will also further automate our processes. So there's a possibility that that closeout automation that we can run automatically. We can start pulling schedules across the whole of our models instead of opening each model and pulling that out. It will provide a dashboard with some health checks for our models that we can monitor if something's going wrong with our models. It will also provide some 3D viewing capability that we don't currently have today. And with that pretty much wraps up our overview of our processes, and we'll open it up to questions.